Hey everyone! Welcome back to our channel. If you're joining us for the first time, I'm Your Name, and today we're diving into the intriguing world of machine learning. Specifically, we're going to explore a fascinating concept called embedding. So, grab a snack, get comfy, and let's get started. Now, you might be wondering, what exactly is embedding, and why is it important in machine learning? Great question! Let's break it down. At its core, embedding is a technique used to transform high-dimensional data into a lower-dimensional space. Imagine you have a dataset filled with words, images, or even users. Each of these items can be represented as a vector, a list of numbers. Embedding helps us represent these items in a way that captures their relationships to one another. For example, let's think about words. In traditional methods, words might be represented as one-hot vectors. So, the word cat could be represented in a list where it's the only word marked with a 1 and all others are 0. This means if you have a vocabulary of 10,000 words, the cat would be a vector of 10,000 numbers, most of which are zeros. Not only is this inefficient, but it also doesn't capture any semantic relationships between words. This is where embeddings shine. With techniques like word-to-vec or glove, we can transform cat, dog, and fish into vectors in a lower dimensional space. The magic lies in how these vectors are positioned. For instance, in a well-trained embedding space, we might find that the vector for cat is closer to dog than it is to car. This proximity captures the similarity in meaning. To give you a clearer picture, let's take a look at a simple example. Imagine a 2D plane where the vector for king might be 1, 2, the vector for queen might be 1, 3, the vector for man might be 0, 2, and the vector for woman might be 0, 3. Now, if we subtract the vector for a man from the king and add a woman, we find that it's quite close to queen. This property of embeddings is known as vector arithmetic, and it's what makes them so powerful in capturing relationships between words. But embeddings aren't limited to just words. They can also be used for images, users, and even products. Let's say you have images of various cats and dogs in a dataset. Using a convolutional neural network, you can generate embeddings that represent these images in a lower dimensional space. This allows you to group similar images together based on their features, making tasks like image classification much simpler and more efficient. Now, let's talk about how embeddings can be applied in real-world scenarios. One popular application is in recommendation systems. Companies like Netflix and Amazon use embeddings to recommend shows or products to users. By embedding user preferences and product features into the same space, the system can easily find items that are similar to what a user has liked in the past. For instance, if you've watched a lot of romantic comedies, the recommendation system might find other movies with similar embeddings and suggest those to you. Moreover, embeddings are also used in natural language processing tasks such as sentiment analysis. By converting words and phrases into embeddings, machine learning models can better understand the sentiment behind a sentence. This allows businesses to analyze customer feedback, social media posts, and more to gauge public opinion on their products or services. Now, let's touch on some popular techniques for generating embeddings. As mentioned earlier, word-to-vec, glove, and fast text are widely used for textual data. For images, models like ResNet and Inception can generate embeddings that capture visual features effectively. Finally, we can't forget about the power of transfer learning. Pre-trained models can be used to generate embeddings for your specific dataset, saving you a lot of time and computational resources. So, to wrap it all up, embedding is a fundamental technique in machine learning that allows us to represent complex data in a more manageable way. By transforming high-dimensional data into lower-dimensional vectors, we can uncover relationships, similarities, and patterns that would otherwise be difficult to identify. Whether you're working with text, images, or user data, embedding plays a crucial role in making sense of that information and improving the performance of machine learning models. If you found this video helpful, please give it a thumbs up, subscribe to our channel for more educational content, and share it with your friends. And if you have any questions or topics you'd like us to cover next, drop them in the comments below. Thanks for watching, and we'll see you in the next video.